Hi, my name is Max,
Hi, my name is Logan.
and our topic for today is writing and solving equations in slope-intercept form and standard form.
When making these equations, we'll be needing two formulas. One for standard form is ax plus by equals c.
For slope-intercept form, our formula would be y equals mx plus b.
Okay.
So the first problem that we have is a child is eating an ice cream cone that is 12 centimeters tall. It's hot outside, so the ice cream melts at a constant rate of 3 centimeters per minute. How much ice cream would be left after 3 minutes? So first, we need to come up with an equation in order to solve the problem. So in the problem, we can see that the ice cream is 12 centimeters tall. So that's going to be our y-intercept. So first, we could write y equals mx plus 12. Now, we need to figure out what is our slope. In order to figure out our slope, we need to see where it is in this word problem. So right here, it says constant rate. Whenever you hear the word constant rate, that means that that's where you're gonna find your slope. So right here, constant rate is 3 centimeters. So it's gonna be y equals, before we move on, notice it says melts at a constant rate. When it says melts, that means it's decreasing. When it's decreasing, we need to add a negative sign behind the 3. So it would be y equals negative 3 x plus 12. Now that we have our equation, we just need to plug it in. We need to plug in 3 in order to get our answer. So we do negative 3 times 3 plus 12, which negative 3 times 3 would be negative 9. Negative 9 plus 12 is equal to 3. So our y would be equal to 3. Now, for the graph, our graphing part, we need to look at our equation. So we first need to begin with the y-intercept. The y-intercept is 12. So first, we put a point at 12. So that's our y-intercept. And then, since there's a negative 3 in our slope, that means we will be going down. We won't be going up, or else that would be wrong. So we go down by negative 3, we will be doing rise over run. And since it's not a fraction, we'll just be going down 3, and then to the right 1. So then we go down 3, which would be 9, and then over 1. So then, let me do it again. Down 3, and then over 1. And then one more time, down 3, and then over 1. And this is how we get our graphs. Now we put a line through it. And that's how we solve for the slope-intercept form.
Now for standard form. You want to earn $1,000 teaching children how to swim. You earn $10 per hour for every individual lesson and $25 per hour for group lessons. Show how many of each lesson it will take to reach $1,000. So now we'll just plug it in. C is the total. So the total is what we want to earn, $1,000. $1,000, right? Now, $10 per hour is an individual lesson. So we can make that, how about, I don't know, x, 10x plus the $25 per hour, which is the group lesson, which will make y. 25y. Now for this, when we're solving these, we have to make a single variable a 0, so we can solve for one variable. For the thing, right? The example that we're using, 10x. So for 10x, we'll take away 25 and make it 0. Parentheses, cross that out because you can't multiply 25 by 0. So then we'll be left with 10x equals 1000. Since we need just to find the x, we had to divide both sides by 10. The 10 will execute the other 10 from the 10x, and we'll divide the 1000 from the 10. What? 10 from 1000, which will be left with x equals 100. Now we do the same thing for the other side. 10 parentheses 0 is plus 25y equals 1000. Cross this out. 0 by 10, not possible, you have 0. So then we'll be left with 25y equals 1000. Divide both sides by 25 and then have y equals 400. Since y is 400, I'll have to make it 400. So this will be 200. I'll just go by 200s. 400s. This will be 200. 400. Now because this is the x, this is the y, x is the 100 right here, and y is 400 right here. And there we have the 2 points. And these will be our numbers to reach 1000. Now what I learned is that you need to have to cancel out a single variable to figure out another variable. Max, what did you learn today?
Well, we learned how to make an equation into slope-intercept form in order to solve the problem. So, yeah, that's what we did.
All right.
Thank you, everybody.
Thank you.